In this lesson, we're going to focus on what's called the order of a Nurbs curve. If we take a look at the parameters for this curve node, we see that we have this parameter for order, and the default value is for an order of 4. When we're working with curve order, we're controlling what's also known as the degree of a curve, but using a different unit. If you're coming from another 3D application, then you might be used to working with a curve degree value, but it's simply the case that the degree of a Nurbs curve is always 1 less than the order. So with an order of 4, we've got a 3-degree curve. The order is the number of control vertices, or in Houdini terms, we could just say the number of control points, that influence the shape of the curve at any given position along the curve. In practical terms, the higher the order, the less the local influence a point has and the more global influence it has. At an order of 2, only 2 control vertices at a time are influencing the interpolation of the curve, and so the curve is drawn from point to point and we get a linear interpolation, which is identical to the way that points are connected by a polygon curve. An order of 2 curve is also what's known as a 1-degree curve, and this is the maximum local influence and the minimum global influence that a control vertex can have. If I select to move one of these points around, we can see that the segments of the curve which are directly attached to it are only being influenced by 2 control points at a time. We only have 1 control point which defines the start of the segment and 1 which defines the end. Moving this point has no influence on the shape of the curve beyond the second point from the one which I'm moving. These sections at this end of the curve and this section at this end of the curve are completely unaffected by the position of this point. If I increase the order to 3, the curve's no longer travelling directly from point to point, because we now have 3 points influencing the position of the curve at any given point along its length. As I move this same point again, we can see that the shape of the curve in this area is being averaged or smoothed between these 3 point positions. With an order 3 curve, we still have a fairly large degree of local influence versus global influence over the shape of the curve. If I increase the curve order to 4, we now have 4 control points influencing the position of the curve at any given point along the curve, and so we get a smoother curve with less deviation. As I move this same point again, it's now having a slightly wider range of influence along the curve, but slightly less local influence around the point of the curve closest to it. It's a little hard to see with a small movement, but if I zoom right out and make a much more extreme movement with this point, we can see that with this order value of 4, this section of the curve between this hull here and this hull here is being influenced to some degree by this control point which I'm moving. If I switch the curve order back to 3 and do the same thing again, we see that we're not really having any influence on the curve beyond the midpoint of those same 2 primitive hulls. As we continue to increase the order value, each control point has less local influence and more of a global influence on the curve, because the curve's position is being averaged or smoothed between a larger number of points at any given position along the curve. As I increase the order above a value of 9, we see that we get a warning badge on the curve node in the network editor. If I bring up the node info, we can see that it says that we need 1 or more points to be specified, and that's because we need to have the same or more points than the order value. And this makes sense now that we know that the order is specifying how many points are controlling the position of the curve at any given point. So to have an order of 10, we need at least 10 control points. With a closed curve though, we can have an order which is 1 higher than the number of control vertices. So if I close this curve, and I'll just move these 2 points here so that it's not getting twisted, we can see in the network view that warning badge has disappeared. If I bring up the node info, we can see that we still only have 9 points and 9 vertices, but we have an order of 10. If I increase the order to 11, we get the warning again telling us that we need to add more points for this order value. So with an open curve, we need to have at least the same number of control points as the order, but in the case of closed curves, we can have an order value which is 1 more than the total number of control points. Let's take a look at another example to help understand this order parameter. I'll step up to the object level and I'll turn on this reference curve which I've drawn, and I'll also turn on this second geometry container and dive inside. The reference curve in the other geometry container is coloured this bright pink. And in here I've drawn 4 curves where I've tried to match the profile of that reference curve. All these curves have the same number of control points, they each have 6, but each curve has a different order. The first curve has an order of 3, And so each point has a high degree of local influence, which makes it pretty easy for me to match the shape of this particular reference curve. What I want to make note of though is how close the control vertices are to the curve itself. This second curve has the same 6 points, but an order of 4. And we can see that to match the curve as closely as possible, I've had to move the control points further away. If I toggle the selectable template flag on and off for the order 3 curve, we can see that those control points are closer to the curve on the order 3 curve than they are on the order 4 curve. When I set my display flag on this next curve, which is an order 5 curve, we can see that those points need to be moved further away still to control the shape of the curve to match the reference curve. And then this last curve has an order of 6, which is as high as I can go with only 6 control points. And we can see again that the control points have to be further away from the curve than they do with the curves of the lower order. If I adjust one of these control points on this order 6 curve, we can see that it's having some degree of influence right at the other end of the curve. But if I do the same thing on this order 3 curve, we can see that it's having very little or even no influence at all over that same end segment of the curve. So the curve order defines the range of influence that a control point has on the curve. The higher the order, the wider the range of global influence, but the lower the amount of local influence. In practical terms, for the kind of work that we typically do in Houdini, curves with an order of 3 or 4 are the most commonly used. Product and vehicle designers working in Nurbs CAD packages might use higher order curves like 5 and 6 for a higher degree of accuracy, but I tend to find that an order of 3 or 4 is the most practical and useful for working with curves in Houdini. It is useful though to have a look at the higher orders to help understand what the parameter does. These commonly used lower order values have specific names, which are worth briefly mentioning because they do come up in a few other places in Houdini, such as in the animation editor. An order 2 curve is known as a linear curve, an order 3 curve is known as a cubic curve, and an order 4 curve is a quadratic curve.